All right, everyone. Hello and welcome to the first video for Physics 40C. My name is Brija, and this is going to be the first video in a series that basically twice a week we'll be trying to outline some concepts for you guys and give you some quick videos that, say, if you were studying or if you just needed the really important concepts, that this could be a possible resource for you. This isn't meant to be a substitute for reading the textbook or watching the lectures online. This is just meant to be yet another resource for you to aid in your studying and your homework. Maybe if a concept wasn't as clear as you could have liked it, this is just another option for you. So today we're going to be doing Intro to Electric Fields. Also known as E-fields. And just kind of outlining the most important principles and the most basic concepts. So you can't be talking about electric fields without talking about the two charged particles that we know to exist in the world. So there's going to be protons and electrons. And I'm drawing them the same size here, but for relevance, the protons are typically much larger than the electrons. That being said, they both carry the same charge. So even though the proton is bigger, it doesn't mean that the charge is stronger. And that base charge is going to be basically the elemental charge, which is 1.60 times 10 to the negative 19 coulombs. So a proton would have a charge of positive E, and an electron would have a charge of negative E. So the way that we tell a charge for any object, so whether that's just a single atom or a larger object like a battery or even just a balloon or a table, anything can hold a charge theoretically. We have this formula for charge. So Q is often what we use to refer to as charge. And charge is equal to the number of protons that an object has times this E value minus the number of electrons that an object has times this E value. Okay, and so basically what that means is the sum total of the protons minus the number of electrons is the charge that that object has. So some important things to observe about charge is that it cannot be created or destroyed. Basically that it's conserved. Sorry. And there are two basic classes of objects that we talk about when observing charge and how it deals with it. So a conductor and an insulator are the two classes of things with charges. I think at this point it's important to note, I'm actually going to put it down here in real big letters, that, that in objects, electrons can move and protons cannot move. So I think most of us are already familiar with this. Protons are typically what makes a certain element an element. So hydrogen, for example, has a proton count of 1. And so if protons were able to freely move, we'd all be in a lot of trouble because that means any element could typically become any other element. So we typically just think of electrons as the things that move and change the charge of an object. So if an object is gaining more positive charge, that basically means that it is losing electrons. And if it's gaining a negative charge, that usually means that electrons are coming towards or going to the object. So the difference between a conductor and an insulator is that these electrons, I'm going to draw the little minus right there so you guys can see it. Electrons move freely. So the most famous type of conductors are metals. And so the electrons can kind of bounce around, and they like being, they're not tightly bound to the nucleus in any way. But an insulator, the electrons are tightly bound to the nucleus. And so if you remember, the nucleus of an atom is the thing that stores the protons and neutrons. So again, protons are not moving, but the electrons that float around it are the thing that gives an object a charge or not. So I'm going to go ahead and go on a new page. Hopefully it just works. And so when we're talking about protons and neutrons, we typically talk about the amount of force that one charge can have on another. So the force of a charge on another is typically called Coulomb's law. Oops. So Coulomb's law is written as F is equal to K, absolute value of Q1, absolute value of Q2, over R squared. So this is the formula that we use when we're given two charged objects. For this first part of the course, you're going to be looking mainly at charged particles and how, when we bring them together, what force that they have on each other. So I'm sure you've all heard before, opposites attract, and that is true in physics as well. So positively charged objects and negatively charged objects will typically want to move towards each other. So if you are dealing with a problem that is having you tell the direction of movement, if any, if the objects are oppositely charged, it will typically be towards each other. And so the reason for this is, release this, is that protons typically, or positively charged objects will typically emit electric fields going outwards. And negatively charged objects will emit electric fields going inwards. So as you can see already in the middle here, we kind of have this line going inwards. Now this doesn't necessarily mean that only the positive charged object is going to move. It just means that there is a clear desire of both of these objects to be closer together. So if the positively charged object is the only free one, then it'll move. But the negatively charged object could also feel a force on it in that direction as well. So both of them in the forces, let's see if I can draw it in a different color. Forces are going to be towards the center. They want to hit each other. Now, one important object to note about this Coulomb's law is this K constant here. And so K is called the electrostatic constant. And it has a value of 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. And so that constant is just something that we multiply towards all of the other things to get force. And as you can see, that's where we get this Newton value from. So all of the terms cancel out to just give you newtons. So once we start dealing with force problems, you're going to see and start dealing with vector addition and subtraction. So if you guys are not as confident on that, your old calculus textbooks or maybe even your old notes could give you a more clearer synopsis, but I'm going to try and just kind of provide a general rule of thumb if you're a little fuzzy on it. So imagine you have two force vectors right here. So this is both F and this is another F, right? And so you have one pointing in the +3 in the X direction, and the same force vector would have a, let's say, +4 in the Y direction. So I like to say that all vectors are secretly just triangles in disguise. No matter what shape the vector is, you can always draw a right triangle. And that can be really, really useful when you're doing this kind of analysis. So knowing your trig functions and things is definitely going to help you in this class. So the magnitude for this vector would be 5. 3 squared plus 4 squared equals 5 squared. So this is a very similar vector, but a little bit different, the second vector here. It has a x value of -3 and a y value of +4 again. So the magnitude of this vector, -3 squared plus 4 squared, is 5 squared again. But once you start adding the components together, you realize, oh, well, I can't just add two vectors going in different directions. I have to add the components. So these x's get added together, and these y's get added together. So the resulting vector is actually one just pointing straight upwards, and it has a magnitude of 8. Okay? So this is just a really quick synopsis, really a demonstration of vector calculus and what the addition process can look like. So if this was confusing to you, you're more than welcome to reach out to your SI leaders whose session times are posted on iLearn. Your discussion leaders also should be able to help you, and then the professor. But this is just kind of the basics on forces and how to start dealing with electric fields. And so thank you so much for tuning in. Come back in a couple of days and we'll post another concept video.